Up.
How's it going, bro? You hear me?
Yeah, it's good.
Uh,
You?
yeah, it's good. Yeah,
Were you
good
able
big
to do
week.
that Prism one?
Yeah, I was able to do that one. I barely passed though.
All right. What's up next then?
I believe it's operations on rational and irrational numbers.
Hmm. Operations on rational and irrational numbers.
Yeah, I tried looking at videos, but I couldn't. They weren't really teaching you anything besides like the rational and irrational numbers. Yeah, I don't know what the hell they're
Yeah,
talking
like
about.
what they are.
Yeah,
Um. Okay, rational and irrational. Yeah, so a rational number just means that you can write it as a fraction, and an irrational number means you can't. Like, there's no way to do it. Yeah, let's just oh wait a minute. Rational, irrational.
want to see one?
Yeah, let's just see one and then we'll go from there. I don't know cuz it
Okay.
can get pretty complicated. I just don't know how complicated it's going to be. Just yeah, it's
Okay, sure.
operations, so rational and irrational. Yeah, let's see.
Let's see it. So
Okay.
this is and what's a irrational number then?
So an irrational number, there's two ways that you can kind of think about it. kind of think about it. A rational number means it's like a whole number because you can write that as a fraction just by putting a 1 on the bottom. It doesn't change the value of the number. So 4 is rational because it's a whole number. That 2 over 9 is rational because it's already written as a fraction. The 8.266666666 repeating, that is also a rational number. So like the three ideas for rational is whole number, fractions, and repeating decimals. All three of
Okay,
those things are rational numbers.
rational.
But you can't have like so for the fraction, it's got to be like integers. It can't be like the square root of 2 over 9. That would be irrational. So square roots, a lot of the time, unless they're perfect squares, uh, they are irrational. So I think the answer here would be square root of 11. But another way to think about it, if you type in 11 on the calculator and then hit the square root button,
Yeah.
the decimal doesn't ever repeat the numbers. Like there's not a pattern. It's not like 316, 316, 316. They're all different numbers forever. Like it's never repeating. That's an irrational number when the decimal doesn't repeat. The
Okay, so it's
contrast.
1.2357. Whatever it was, 3333333. Then I would.
Yeah, so like that 8.26666666666, that it starts to repeat, so that's a
Yeah.
rational number. But if you did the square
Okay.
root of 11, you can hit that square root button. It should be 3.316624790. It never repeats. It just a whole bunch of random different numbers. Do you get that?
And the square root is the 2 over the x, right? Not the 3. That would be
The
on
cube
the
root.
calculator.
It would be with that little like the check mark division box kind of thing
Yeah,
with the 2 in it
with
is
the
the square
x.
root.
Okay, that's the square root one.
Do you get 3.3166 something something?
Yeah, 3.1624.
Yeah. Okay.
I'm going.
So rational is whole numbers, fractions, or repeating decimals. And then irrational is most likely square roots or just decimals that don't repeat.
Okay.
Yeah. Okay, the sum of two rational numbers will always be a rational number.
Rational number.
Yeah,
Right,
so
right.
like
Yeah, I think they mentioned that in the video.
if you add two whole numbers together, those are two rational numbers, you're going to get a whole number. So that's your answer is going to be a rational number. If you, and then when it says sum, that means adding. So the sum of two rational numbers will always be a rational number. If you added two fractions together, you'll still end up with a fraction, and fractions are rational numbers, so it works for the fractions. And then for the repeating decimal part, if you add two repeating decimals, in the end it'll still be repeating. So it'll still be a rational number. But that's kind of like a rule that you can think of. If you add two rational numbers together, whatever you end up with will also be a rational number.
Cool.
And it's like the same thing with subtraction. All right, which statement is true about the sum of two rational numbers?
So.
Okay. So I said there was three categories for rational numbers, and the three categories are whole number is a rational number, a fraction is a rational number, and a repeating decimal is a rational number. But the big idea that captures all three of those is for any rational number, you can write it like a fraction. So just from the question before, if you add two rational numbers together, you'll end up with a rational number. And you can always write a rational number as a fraction. So it'll be that first one.
The first one.
Yeah, it's kind of like just a lot of rules for what is rational and.
So a rational number could be a whole number. All right.
Yeah. So rational number
could be written as a fraction.
Yeah, a whole number is a rational number. A fraction is a rational number. And a repeating decimal is a rational number. But all three of those, no matter what, you can always write all three of those situations as a fraction. With the first one, there's like you just put it over one. The second one, if it's written as a fraction, it's already written as a fraction. And for the repeating decimal, there is a way to write it. I don't remember. I don't think it'll get into that, but you can always write a repeating decimal as a fraction as well. Whoa! All right.
Such simple ones before, and then
below is a proof showing that the sum of a rational number and an irrational number is an irrational number. Okay, so that's saying, like, if you take a rational number, let's say the easiest rational number would be a whole number. Say you take a whole number, which would be the rational part, and add an irrational number. So you add a non-repeating decimal. It's like the square root of 11, like we did before.
Okay.
It's just like adding the whole number parts before the decimal. You just add those up, but then you'll still have the non-repeating decimal part. So then what you end up with, if you add a rational number and an irrational number, it'll be forced into an irrational number. But then it has this proof. Okay, let A be a rational number and B be irrational. I think this one's overly complicated.
Yeah, they're throwing a lot.
X plus negative a is rational because the sum of two rational numbers is rational. It would be the first one. It's
complicated.
Yeah, so they're trying to do this is called a proof by contradiction, where you assume something. So when it says assume that a plus b equals x and that x is rational, if you assume that x is rational and then you get some kind of contradiction, then whatever you assumed has to be the thing that's wrong. But really, when it says x plus negative a is rational, they're talking about the rule where you add two rational numbers together and your answer will be rational. That's what it's trying to get at. So that's why it's the sum of two rational numbers is rational. So like x plus negative a is rational because it is the sum of two rational numbers. When you add two rational numbers together, you always get a rational number. Um, yeah, I don't think it's important to understand the rest of that proof.
Okay.
But this one, let's see.
And they would just add those two?
Yeah. I think it depends on how you do it, but well, it can't be
Or
the
they would
first
fix it and
answer. The sum is a terminating and a repeating decimal. If it's repeating, then it
it's
means
not
it never
rational. Or I mean,
terminates.
it's not irrational.
Wait, so 2 3/4 or negative 2 3/4, that's already written as a fraction, but you can change it into a decimal, negative 2.75. I guess that's actually another category for a rational number, is any terminating decimal. So maybe add that to the definitions of rational numbers. Any terminating decimal.
Any terminating.
So any terminating decimal or any repeating decimal. The only kind of decimal that's irrational is when it's non-repeating and it goes on forever. So like 5 divided by 9, that's repeating 0.555555555555555.
Okay.
And then 2.75. So if you add that plus 2.75 negative, you get a repeating decimal. The sum is a non-terminating and non-repeating. So the second one is also wrong. It's definitely not an integer. It's the answer is the third one.
Fraction?
Yeah, because any said it before, but it's, I don't know if you remember, just because it's so many things, so many definitions, but any repeating decimal can also be written as a fraction.
Oh yeah.
And so if you change those both to decimals and add them together, you get another repeating decimal, and any repeating decimal can be written as a fraction. Okay, pi is an irrational number. What's that?
What was the pi again?
If you hit the pi button on the calculator, it'll show you.
Yeah, okay. Yeah.
So, and then it's like the decimals go on forever, but they never repeat. So pi is irrational. So you have a rational number, 4.5, because The four categories for a rational number is a whole number, a fraction, a repeating decimal, or a terminating decimal. So 4.5 is a terminating decimal. It stops 4.5. There's nothing else after that. So 4.5 is rational, and then the pi is irrational. So when you add those together, you're going to get an irrational. An irrational means, well, it can't be repeating decimal.
Yeah.
So it's not the first one because a rational plus an irrational is an irrational. So it can't be the first one.
Irrational because it is repeating decimal, but it's not a repeating decimal.
It's not a repeating decimal. It's the third one. Because if you do, like on the calculator, if you do 4.5 plus and then hit the pi button and then equals, you
7.6.
Yeah, 7.6415926 blah blah, and it keeps going. That is irrational because it's non-terminating. The decimals keep going and going and going and going, and it's non-repeating. Like there's no pattern that just repeats over and over.
Okay.
So it's the third one. But that's, I guess, another property of rational and irrational numbers. Just like if you add two rational numbers together, you get a rational number. This other rule is if you add a rational plus an irrational, you end up with an irrational. That's another rule.
If you add an irrational and a rational?
An irrational and a rational. If you add them together, you get an irrational. So many weird terms.
Yeah, there is.
Like this is when it's like gets into not stuff you use often or ever.
Okay.
The sum.
Yeah. I figured this is like the first course of this. I think this is like the decimal one. I think.
Yeah.
It would probably be like involving money or something.
All right. The sum or product of a non-zero rational number. Irrational is always. So the sum, that means when you add them together, and the product means when you multiply them together. So it says the sum or product of a non-zero rational number and an irrational number is always, well, one of the rules that we already talked about is the sum of a rational and an irrational gives you an irrational. And then the product. Well, let's do a rational number like 2.5 times an irrational number. Let's do times pi equals. And you get an irrational number.
Plus pi, right? Or times?
Times. I was trying to test out the product. 2.5 times pi. You get an irrational number.
Yeah, 7.85.
Yeah. So I think the sum of a rational and irrational is always irrational, and the product of a rational and an irrational is always irrational. So I think it's the second one.
Irrational.
Rational. I think you can get this one.
Yeah, I was gonna just try to do. Building A.
Correct. It's not A.
B.
Why not B?
I don't know. I don't know if I did it correctly. Like that. Let's see.
Here's one way to do it. Uh,
Like the fraction.
yeah, to do the fraction in the calculator. So 2 divided by 3, what do you get?
I got the 0.6. I mean, I think it was like 0.66.
Yeah.
667.
So 0.66 repeating.
Yeah,
So that's rational. And then plus 9.26 is 9.
Yes, 9.9260. I just thought that the 6 had to keep going, so they can't be like that 7 at the end.
So that's only because the calculator does that. It rounds that last
okay.
one, just because it can't show an infinite number. But whenever that
okay.
happens on the calculator, where that last number is different, it still just means it's repeating 6 forever.
Oh, okay. So it is that one then.
Yeah. So you get a repeating decimal, and a repeating decimal is still rational.
It's rational, yeah.
And if you did all the other ones, like that 5.787652, when they show the dot dot dot, they're saying that decimal keeps going on and on and on.
Number.
But it's not repeating yet. So it's all different numbers on and on and on. So you're going to have an irrational plus that 4.3 repeating, or 14.3 repeating.
So that dot doesn't mean that it's 99999. It just means it keeps going, but
yeah, it keeps going, and we don't know what it's going to be.
Okay.
So you see the little bar over the 3 on the 14.3? Yeah. That means the 3 keeps going. So if they wanted to say that it goes 9999999, they would put a bar over the 9. Okay. So yeah, the dot 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 means it's just keep going, random numbers.
No.
This one's a silly one. So it's gonna be the formula for the area of a circle, because the formula for area for a circle, this is actually, I think, good to write down. I think we talked about it once, but the area of a circle, A, equals pi times r squared, and the pi is irrational. So even if you use a rational value for the r, which is what it's saying, evaluated using rational values for the variables, even if you use a rational number for r, you're multiplying it by pi, and that always just makes it irrational.
Oh, okay.
And then the other formulas, they all just have rational numbers in their formula. They don't use pi at all. So those ones will all be rational. Yeah, this one's a weird one. Hopefully the next one won't be so definition heavy. The product of two rational numbers can always be written as
a fraction, right?
A fraction, because it's also a rational number. Yes.
What about, wouldn't it be a whole number too?
Not every time, because it says always.
Oh, okay.
Yeah,
always.
So like if you did 1/2 times 1/2, that would be like you multiply straight across the top, straight across the bottom. That would be 1/4. It's still a fraction. You can write any number or any whole number as a fraction, or fractions just are fractions. So, like 1/2 times 1/2 doesn't end up in a whole number, but it's still rational, and rational means you can write it as a fraction.
All right. A fraction is.
Yeah.
Let's see what we got.
All right, what's that next one? Quantitative reasoning. I feel like this one's going to be a weird one, too. I don't know what this means, actually.
Oh, you want to just go into this?
Yeah. Quantitative reasoning. I feel like it might be word problems, but... Oh, did it kick you out?
Yeah. Seems like it's giving me what is this? Oh, okay. There we go.
Okay. Okay, wait. I just want to make sure we're reading this graph the same way. So like, would you be able to tell me what the temperature would be at 12 midnight just from looking at the graph?
Yeah, let me see. It would be at 12 would be 0, right?
Yeah, and then like at 1600 hours, what is that? 8 o'clock?
It'd be 8.
8. Okay, perfect. Okay, so for that 4 p.m. 4 p.m. occurs 16 hours after midnight. Oh.
Select the answers.
8 a.m. Okay, so it's 8 a.m.
The temperature increased until 4 p.m.
Do you think that looks right?
It doesn't look, no.
Because you see at 8 a.m., it's -4 degrees.
Yeah.
And then at 10,
okay.
it's -2.
10,
At 12, it's 0.
0, and then
14.
To,
it's going up, right?
yeah.
So that one actually, I think, does check out. It has a positive slope. It's going upwards from left to right.
Up, yeah.
So that means the temperature is increasing until 4. So 4 p.m. 4 p.m. is 16. Yeah.
Okay. I got it. Yeah, so I didn't read that. 16. Well, I did read that. 16. Good.
4 p.m. is 16 hours.
Which is wrong.
Yeah, because at 16 hours, the temperature is 8 degrees, right?
Yeah.
At 17 hours, like right in the middle of that flat line, at 17 hours or whatever, it's still 8 degrees. So it is recorded. It's just not changing. So that one's not true. We don't check that one. Because it was recorded, it just didn't change.
The temperature decreased after 6.
And 6 was 18.
18, which is correct.
Yes.
Decreased.
Mm-hmm.
The temperature increased and then decreased before holding. That's not true.
Right. What happens, actually?
It increases, then it stays constant, and then it decreases.
Perfect. Do you understand that last one?
Yeah, it spiked, right? It increased more than, because it jumped from 12 to, well, from 0 to 4 within the two hours or whatever, from 12 to 14. And then the same with the 16. Within the case of when it started from 12 Wait, let me read that. The
'Cause-
temperature increased more quickly between 12 p.m. and 4 p.m.
so
than
12
before. Yeah,
p.m.
yes, that's right.
to 16. Yeah, there's a
Yeah,
huge jump. And before that, another way you
It
can think
was
of that is the 12 to 16. That one's really steep. And then before 12, it's less steep. It's still like
that's the slant.
still an increase, but it's slanted less. So that that's talking about quickly. Like really quick is slanted a lot. Not as quick is slanted less. But okay, that one's not. I mean,
That one was pretty cool. Yeah.
yeah, more understandable than the other one, I think. What are you thinking on that first answer?
I think it's correct. Wait, let me see the last. And then gradually, no, that doesn't gradually. What'd you say? The heart rate increases for 6 minutes, which it does bump up.
Uh huh.
Remains constant for 19 minutes, and then gradually increases. Well, it doesn't. It decreases after
It
that.
decreases afterwards. So the first one's not right.
The second one isn't even.
Right,
It
because
gradually increases. It's the same crap as A kind of.
mm-hmm.
Oh, it decreases. He's saying
Yeah,
actually for the first 6 minutes. Yeah, so it's C.
yeah,
It's the last one.
yeah. Not too bad. This is hopefully
Yeah, these ones ain't bad.
interesting. Let me know if you want me to explain it, but if you want, you could take a guess. If you or you can do it if you think you have an idea.
So Kristen returned a book, her overdue book, to the library. Her mind is the same as the amount on the following day. Out of the line shown. So what it's trying to say is like she returned it out of the fine shown below, which
I think it's saying like she returned it on some day, and if even if she didn't return it the next day, she would have had the same fine.
oh, okay.
So which fine did she pay?
It would be 10.
Yeah, because like say she's on like day 6, the fine would be 3, right?
Mm.
Well, the next day, day 7, you move over a little bit, but the fine would be a little bit higher than 3. So it can't be that for the fine because the next day was more. The only time where the fine doesn't keep getting higher and higher is on that flat part, and that flat part is on 10. So if you go the next day, yeah, it's still just 10, and that's what it's trying to get you to see.
Okay, I see.
And it's important when they say out of the fines shown below, because if they said what day could it have been, you could have said it could have been like 21 days or 24 days or 27 days, because that's when the fine is not increasing anymore. But it's important that they said the fines. You're supposed to pick out the fine that she was paying, not the days. So yeah, it would be 10. Okay.
Definitely not B.
Correct. What do you think about A?
I mean, that one, Bryn was wrestling at a constant climbing, which is false.
That's false.
I think it's the last one, right? Both climbers, because they both wrestled for 2 minutes.
Yep, because Bryn's was from 5 to 7, and Abby's was from 4 to 6. Yeah,
4 to 7.
that flat part is where they were resting.
Yeah.
Cool.
The dog stopped and laid down because it's just stay there, right?
It looks like that.
But the dog was running towards the trainer to receive a treat. It could.
But it said 5 seconds after the command was given, so that's like halfway. The dog was getting closer. So like the dog was maybe going closer to the trainer at 5 seconds, because the distance is decreasing. And it says 5 seconds after. The dog was running towards the trainer. At 5 seconds, the dog is running towards the trainer because the slope is decreasing, or like the slope is going downwards. That's at 5 seconds. At 6
right.
seconds, that's when the dog would lie down, I think.
It stopped, right? Yeah, the dog stopped and lied down. But the dog was stopped and began running towards the train.
So it's definitely not the last one. The dog was stopped but began running towards the trainer. So right when the command was given, that's at 0 seconds. And the dog was getting farther and farther away when the command was given. Then the dog started getting closer and closer, and then the dog stayed whatever distance. So I would say
3 seconds.
the dog's. Which statement could describe the dog's movement 5 seconds after the command? The dog was running towards the trainer to receive a treat. I would say B. Just because at exactly 5 seconds, the dog is currently moving towards the trainer.
Okay.
At 6, 7, 8, or 9 seconds, that's when we could say the dog lie down. But it said at 5 seconds.
All right. Let's say weeks 1 to 3, right?
So
the highest average of.
But look, so the right column, it says average time on hold. So on week 1, the average time on hold was 7 minutes. Week 2, the average time on hold is 5 minutes. Week 3 is 3 minutes. Week 4 is 2 minutes, and so on. So far, so good?
Yeah.
Okay, and then the question says, according to the table, during which interval did the average time spent on hold increase? So if we look at
It was
week
already
1 to 3, that's going
down.
from 7 to 5 to 3. That's decreasing. From 1 to 4 is 7 to 5 to 3 to 2, still decreasing.
So it'd be freaking 4 to 6.
Right, because you're going 2, 3, and then 5.
And then 5 it just going. Oh, I see. Yeah.
That's all increasing from 2
Yeah.
minutes,
it's
and then 3 minutes the next week, and then 5 minutes the next week. That's all increasing.
Got it.
From 3 to 5, that would be decreasing and then increasing. So
and then increasing.
So it's the same question?
It's the same chart. It'll be 18 feet higher, right?
So Abby, how high did Abby climb above the original starting? So she got to 22, but she started at 4. 22.
She started at 4, right?
Yeah,
So.
yeah, 18. They're trying to trick you with that 22 there.
Yeah.
With the original start. Yep.
This one right here.
Yep. It doesn't mean that they're stopped. It's the speed is just constant. The speed is not changing. The only way Jamal would be stopped is if, like at 0, when it touches the x-axis, when the speed is 0, and that's just when he's starting out. So, cool.
Yeah, that one. So it's jumping by 15 for every freaking 10 songs or
Mm-hmm.
files.
15, 30, 45, 60, 75. Yeah, by 15. So the number of files remains constant. Well, the number of files is increasing by 10 each time.
Yeah, so it's not
So it's not that first one. Or the second one.
Is it constant because it's going by tens, like for B?
As the number of files remains constant, the storage space used increases. So that would be saying if it was like 10, 10, 10, 10, 10,
Okay.
and then the space used would be 15, 30,
So,
45, 60. But the number of files is not remaining constant. If
yeah,
you like look at that, it's
on a
increasing.
graph, right?
Yeah, as if you had it on a graph. So it has to be one of those the second two answers.
Yeah, I think it's C. As the number of files increases, the storage space. Oh no, that one's off too. As the number of files increases, the storage space use increases. So it's the last one.
Yeah, it's the last one.
So it's the last one too, right?
Well, on the last one,
Well, it stays at a constant, right?
yeah, that one, the speed was 45 and then decreased to 43 and then decreased to 41. So it was decreasing and then it stays constant. That's not what it's asking. It wants.
So it's this one right here, I think.
Yeah, the second one.
Because it goes to 47 and 49 and then it goes down.
Yeah, and then it goes down. Cool. That one was much better than the last one.
Yeah, those are pretty cool.
Oh.
That one wrong.
Which one? What? Out of the finds shown below, which one would be closest to the number of days? Oh, shoot. It did say number of days overdue. So it should have been 21. I read it wrong. I thought it was saying.
It is closest, yeah.
Out of the fines. Wait a minute. It says out of the fines shown below, it was saying that all of those numbers were fines. Which one would be the closest to the number of days? That's confusing.
Yeah, that's why they try to get you.
Yeah, number of days would have been 21 because 21, the next day still has a fine of 10. Out of the fines shown, which one would be the closest number? Yeah, I think that's worded poorly because it's not showing the fines; it's showing days. Your answers are the days. Weird.
Yeah, they always try to trick you with stupid questions.
Dimensional analysis. I feel like that might be probably feels the same as what we just did. Dimensional analysis. I say let's try it. Probably doing something with like shapes and oh. Hmm. Oh, okay. So when you use like fractions to convert, they're converting miles per hour to miles per minute. So really, that second fraction is the conversion. So how many minutes are in 1 hour?
60.
60. So then that's all you're looking at there.
60.
So like if it said 1 hour and then blank seconds, we would have to figure out how many seconds are in an hour, and then that's what we would have put.
Okay.
So this is like maybe conversion stuff. Let's see. Okay. So they give you the conversion 0.7306 euros equals $1. Do you know how to do that?
No, how to convert it now?
So every this is the way I think of it. So that the equation that they give us is saying $1 is worth 0.7306 euros. That like that kind of like like 75 cents almost. Right?
Okay. Oh, I see. It's just
But we need
3,500,
3,500 of those 0.7306. So we just multiply.
Which one of those numbers?
3500 times 0.7306.
What do you multiply it by? The 0.7306?
That is multiplied by 3,500.
Okay. I got 2,576.
I think you typed it in. It should be 2,557.1.
Yeah, I did. I got it now.
So, like, the idea is the 0.7306. That's like that's $1. That's equal to $1. Yeah. So we need to make that conversion 3,500 times because it's $3,500. So for each one single dollar, you're adding or you're like converting it to 0.7306. So it's like 0.7306 plus 0.7306 plus 0.7306. You're doing that 3,500 times. Sense. So that's just the same thing as doing 0.7306 times 3,500. We'll see another one on conversions, I think. One.
Not too bad. How many square inches are that? 6 square feet.
I think this one might be a trick one. Okay, how many square inches are in 1 square foot? That's my question. That's the conversion factor thing.
Same way.
Well, what?
In one, it'd be 1 square foot by 1 square foot, or?
Well, 1 square foot. How many inches is that?
12 inches.
It'd be. How many square inches are in 60 square feet? Yeah, it'd be 12, right? 12 square inches is the same thing as 1 square foot. So, like, I would write down 12 square inches equals 1 square foot. So then now you're just taking the 60 times the 12, I think.
720, something like that.
Yeah, don't. I'm gonna Google that real quick.
Yeah, go for it. I was gonna Google it too just to see if it's on. It should be on Google.
Because I don't know if it's like a trick question or not, but. Oh, it's 8,640.
8,000, yeah.
So how do they do it?
Multiply the area value by 144.
And that's 12 times 12. So there's 144 square inches in 1 square foot. Oh, because it's 12 by 12. So there's
Yeah, so it has like the base, yeah, kind of like the
144.
base thing, right?
Yeah, like the base in the height. Okay. We'll be aware on the next one. We'll try it. But
Yeah.
so it's 12 by 12, so it's 140. Okay, we'll see. Okay.
Gonna be 47. I mean, I don't know. That's a
Well,
finds out a mile 50. I think it's different.
yeah, they're switching between units because Anisha's rate is miles per hour, and Morris is feet per second less.
Oh, okay. One
So
mile equals the. Yeah, I see.
maybe we'll change the 3 feet per second into miles per hour. How do we do that? Oh, uh, 1 mile is equal to 5,280 feet. So it's going to be some kind of decimal. I think 3 divided by 3 divided by 5,280 is some decimal. Miles. That's not right. Yeah, I don't know how to do this one, I don't think. Let me see. Anisha travels at a rate of 50 miles per hour. Oh, it's 3 feet per second. So we have to do miles to feet and hours to seconds. That's the thing. Okay, 50 miles per hour. 50 times.
I looked it up on that, just on Google, and I see it's. They're saying it's 48, but nobody really shows the how to do it.
Yeah. Uh, yeah, click 48 and then save it. Because I think I can walk through it. Hold on, let me take a picture. Okay. So it's saying that so the problem here was we have miles per hour and feet per second. So I kind of want to change the. Oh, that might get weird. Miles per 1 hour. Let me just write this out, and if it's not making sense like quick enough, then we'll just move on. But
Right.
50 miles in 1 hour. That's the same thing as 50 miles. So I'm going to do 50 times 5280. So 26400. I did 50 times this so that I can convert it into feet, because 1 mile is this many feet. So if I have 50 miles, then that means I have to do 50 times that.
Yeah.
So that changed to feet, and then 1 hour is the same as 60 minutes, right? 1 hour is the same as 60 minutes, and then 60 minutes, we want it in seconds. So there's 60 seconds in a minute, so I do 60 times 60, 3,600 seconds. So 3,600 seconds. So this, now we're in feet per second. Morris is traveling 3 feet per second less. If I divided this, this would be 264,000 divided by 3,600. 73.3 repeating feet per second. And this one's 3 less, so it's about 70 feet per second. And now we convert back to miles per hour, which means, yeah, this is too complicated. Let's just leave it at 48, and we'll see if we have another one like that.
It's okay.
Fuck.
Yeah, that one was
not as easy as the other ones.
no, that was a complicated.
$22 to US dollars. Assume 1.2 Australian dollars equals 1 US dollar. So if you have 22 Australian dollars, how many US dollars is it? That's what it's saying. So 1.2 Australian dollars is equal to 1 US. So you're trying to figure out how many 1.2s fit into 22. Does that make sense?
Yeah.
And to figure that out, whenever you're trying to fit, or like how many goes into, that's division. So you do 22 divided by 1.2. So it should be 18. And I think it's the second one, because if you're multiplying by that fraction, you put the like 22 Australian dollars, you can put that over 1 and then multiply straight across the top. That would be 22. And then multiply straight. Yeah, the 1.2 is on the bottom, so you divide. Does that one make sense?
Yeah, yeah.
Okay. I'm going to just say 6.5 feet. That's easier to think about.
Yeah, yeah.
Okay, 77 inches. Let's convert that to feet. Do you know how to do that?
There's 12 inches per foot, right?
So, so how many 12s fit into 77?
be a 6.41.
Yes. So that fits, right? Because
Yeah.
that's less than 6.5. Right.
The bookshelf is 12 inches. Too wide to fit. It's isn't it B? The bookshelf will fit. The bookshelf that is 27 inches wide.
The bookshelf is 6.41 feet, right?
Yeah.
And the two
So
windows are
it's gonna fit.
6.5 feet. So it's either B or C. The bookshelf will fit between the windows with no extra room remaining. The bookshelf will fit between the windows with 1 inch remaining. I think it might be the 1 inch, but let's see. Let's convert 6.5 feet to inches. Do you know how to do that?
No, how would I do?
So there are 12 inches in a foot. So then you just take 6.5 times.
Okay, so it'd be okay. How would you do it? Then take 6.5 and
Times 12.
equal 78. So yeah, you're right because the bookshelf
Yes.
is 77 inches.
Yeah.
You would get it with an inch for me.
Oh, damn. Okay. This is one of the ones, same one as that
Yeah, that weird one.
one that took a long time. 2.5 miles times 6 equals which statement comparing two swimmers is accurate? 2.5 miles per hour comes out to be 1.117 meters per second. So Alina is slower. Talia is 1.8 meters per second. Alina swims about. Okay, so they go to miles per hour. So how do I get to miles per hour? 2.5 miles per hour. Meters per second. Let's see. Per second is 4.02. Alina swims about. Oh, it's the last one. Talia swims about 1.5 miles per hour faster than Alina. Talia swims faster. This is weird. I think I can explain it, but yeah, let me take a picture. I think I can explain this one. It's gonna be weird, but
yeah, I was trying to freaking just figure out 2.5 miles. It's like 4,023.26 in meters, and then
you're going to save and exit, and then I'm gonna share. Excuse me.
push.
Thank you. All right, so all of these are in miles per hour. This is already in miles per hour, so I'm going to keep that. So 2.5 miles per 1 hour. That's fine. Now I want the 1.8 meters per second. First, I have to figure out it's 1.8 meters for 1 second. I want to figure out how many miles this is. And then I want to figure out how many hours this is. I'm converting the meters to miles and the seconds to hours. And it's a weird way that I'm going to do it. But I already know that 1 mile equals 1,609 meters. So if I had, if the question was, which is a completely different question, if the question was like convert 3 miles to meters, all I would do is just take this and multiply it by 3, because I would have, like, for 3 miles, I would have 1,609, 1,609, 1,609. Just add it all together, because this is 1 mile plus another mile plus another mile. Does that make sense?
Yeah.
So that, if I'm converting miles to meters, all I have to do is multiply by 1,609 if I'm converting miles. But I'm going backwards. I'm going the other way. I'm converting meters to miles. So I would really like it is if, like, 1 meter equals how many miles. I really want that equation. Like, I could look it up, or I could use this conversion that they already give me. But that's really the question. I'm trying to figure out how many miles is 1 meter, and I'm going to show you right now. To get that, I just take this and divide both sides by 1,609. So 1,000 divided by, or 1,609 divided by 1,609, that's just 1. And it's still meter, or meters, 1 meters, whatever. And then 1 divided by 1,609, that's going to be some decimal. 1 divided by 1,609 is 0.123615 miles. So now, if I want to convert 1.8 meters into miles, I just take this and multiply it by 1.8. So that's what I'm going to do next. So times 0.0 0.006215. So times 1.8. That ends up with 0.0111871. Now this is in miles. So 1 meter is that many miles, which is just weird.
Yeah.
And then 1 second is how much in hours? Well, that's the same thing as saying like 1 hour equals 60 minutes, and 60 minutes equals 3,600 seconds. So 1 hour equals 3,600 seconds. Well, I want to know how much is 1 second, so I'm going to do the same thing that I did here. Divide. I think this is not making sense. This is too much, I feel like. But if I divide, I get 1 second, the conversion. 1 second on this side, and 1 divided by 3600 is 0.123277778 hours. So 1 second is 0.0002 something something of an hour. It's a really tiny decimal of an hour. So that's what I'm going to put down here, 0.000277778 hours. Now I have miles per hour. I'm going to actually divide these two numbers and see what I get. So 0.0012387. So this ends up being excuse me, 4.027 miles per hour. So that is for Talia. So Talia is basically 4 miles per hour, and the other one, Alina, is 2.5 miles per hour. So that's where I came up with the one. This is so much. This is so convoluted. The whole idea was that if I was converting meters to miles, I want 1 meter equals how many miles. That's the whole question. And to figure this part out, I just divided so I can get 1 meter, because 1,609 divided by 1,609 equals 1, and that would be the meters side. And then do the same thing on the other side. And then that's also what I did here. I wanted to know, converting seconds to hours, I want to have how many hours is equal to 1 second. So still do the same thing. It's a weird one. I don't know. If we see another one, we'll see if we got that one right. I don't know. I shouldn't have spent that long.
It's all good. Hopefully you got it.
I feel like I just wasted a bunch of time.
You want me if you left?
Maybe. I don't know how they would explain that one. Yeah, let's see. The group of fitness club members lose a combined total of 28 kilograms in 1 week.
For this one, we would divide the 28 by 2.2.
There are approximately 2.2.
Yeah, so I got 12.7 if you just divide the 28 kilograms.
So that would be saying how many pounds. That would be saying how many 2.2s fit into 28. But it says 28 kilograms if you're converting that to pounds. 28 kilograms.
Or approximately
It should be
2.2 pounds.
It should be
okay.
28 times 2.2. Because for every 1 kilogram, you get 2.2. So
61.6.
if you have 28 kilograms, that's 2.2 28
Got it.
times. So that would be 2.2 times 28.
61.
Wait a minute.
Oh, yeah, I'm not doing.
So 61.6. That's in 1 week, but it's asking how much did they lose each day. So we had,
I would divide that by 7.
yeah. Right? That's a tricky one.
8.8. Yeah. See, that's how I always get mixed up.
So they converted the 28 kilograms to pounds, and then divided by 7 because it was in 1 week, and they're asking for each day. That's an interesting one. Yeah, you're either multiplying or dividing, and it's kind of hard to tell which one you do. Okay, well.
Yeah, 144, right?
How many inches are? Yeah, yep. Right, because it's 12 inches in every single foot, and there's 12 feet. 12. So, yep. Okay. So we started out with $250. So let's convert that to euros.
Do the multiplication, right? Do the 250 times the 1 point.
1 euro is that in dollars. Now we'd have to divide by that. Yeah, 250 divided by 1.3, whatever. So.
All right, we got 182.6550.
Yeah. Okay. And then now that's in euros, and then minus 150 euros, right? Because he spent 150.
Yeah.
So minus 150. And then to convert back, we multiply that by 1.368. Because to go from dollars to euros, we divided by 1.3687. Now to go back, we multiply by that. So times 1.3687.
I got 44.69, so 47.
Yeah, I think so.
Interesting.
So okay. So here's the thing that's happening a lot. It's usually like in this conversion, it's 1 euro equals 1.6 or 1.3687. Sometimes it's like 1 mile equals 5,280 feet. There's some rule I just can't formulate it in my head. For when you divide or when you multiply by a certain thing. So like if if we were converting a euro to a dollar, we would multiply by 1.3687. But since we're starting out with a dollar, we would divide it. I don't know. We'd have to go over some stuff again. Maybe when we get to the test, we'll try and review something. I'll try. Yeah, let's see what we got. That one right. Yeah.
Which one we got wrong?
Oh. Required. How many euros? Oh, per month.
To the university.
We didn't convert because it's 3,500 per year, and then it's asking for per month. We didn't convert it to months.
So it would have been the 213.
Yeah, probably. Damn. Yeah, I didn't see that it said per month. What's the next one? Maybe it'll be a better one.
Introduction to functions.
What time is that? I think we could do that one. Do you want to try it?
Yeah.
So functions basically is like you're gonna plug something in, and you're gonna get something out. So like the blue, everything in the blue circle is like numbers that you would plug in. It's like you kind of think of it as like a machine, like a little box. You put something in, and the function is the box, and then it's gonna spit something out. So like if for this function, this picture is representing a function. If you plug in a -3, it spits out a -9. If you plug in a 2, it spits out a -6. So that's just the idea of what this function does.
Okay.
The domain.
So this one's kind of giving us the answer right here, kind of like.
Yeah, but the domain is the x values, which is also the input. So the left side, the blue, the input, the x's, the domain, those all mean the same thing. The right side is the y values, and it's also called the output, and it's also called the range. So input, x values, domain, those all mean the same thing.
Okay.
Output, range, y values, that all means the same thing. So here it says what is the domain of the function in the mapping. So the domain is the input, which are the x's, and it's all those numbers that are in the blue oval. So -3, 2, -5, 1, 6.
So it'd be if I would plug in the -3, I'd get -9.
Right, but it's only asking. It's not asking like what do you get when you plug in a -3. It's saying what are the things that I'm allowed to plug in? What are my inputs? And it's just that list. So that the answer is actually A.
Oh, okay, because that's the same numbers that are in there, right?
Yeah, and it's saying what's the domain? It's just saying what are the x values or what are the inputs? Yeah, and that's it.
Oh, okay.
If it said like what's the value when I plug in 4, then you would follow the arrow and go to the y value. So
this one would be B.
Yep.
Is the range of the given function,
yep,
right?
And it's the y values. Yep.
Yeah.
Okay, which explains why the graph is not a function. Okay, there's a weird definition for functions, but if you plug in a single x value, it should give you a different y value. You can't plug in you can't plug in an x value and get 2 different y values for it to be a function. This is just part of the definition of a function. Here, I'm gonna say it again because it's a confusing definition, but for something to be a function, when you plug in an x, you always get the same y value out. Like you plug in a 3, and then a couple minutes later you plug in a 3, a couple minutes later you plug in a 3. All those times you plugged in a 3, you should get the same y value out. You can't have it where like you plug in a 3 the first time you try and you get like 5, and you plug in a 3 again, you should get 5 if you're going to have a function. If you get some other number, then you don't have a function. So the reason this is not a function is if I count on the x values on the x-axis, if I count to 4, I have 2 dots that correspond with it. One is the top one, which has a y value of 4.
Yes.
One is the bottom one, which has a y value of -2. Both of them have the same x value. So that means if I plug in 4, sometimes I get a y value that's 4. Sometimes I get a y value that's -2. That means it's not a function.
So it would be a C, right?
It is not a function because there are 2 different x values for a single y value. It's flipped around. It should be.
Oh, it's the other one. The
single x value.
2y. Yeah.
Yeah, there are 2 different y values for a single x value. You're not allowed to have that if you're going to have a function.
Okay.
So like you plug in an x, you should only get a single y out. And in this case, you plug in an x, 4, and you get 2 different y's. You get a 4 on the y-axis and a -2 on the y-axis. That one, I think we'll like run into that again.
Into some more, hopefully,
yeah. Yeah. So domain again, it's the inputs.
The x, right?
The x, yeah.
And it has to have every. Okay. So it'd be the 3, the 6, the -1, the 5. So it'd be A, right?
Yep. Right. Yeah. So domain is the x values. It's the inputs. Yeah. Domain, x value, and input. They all mean the same thing. Range, y value, and output. That all means the same thing. Okay, you know, on the last one, we looked at, like when we plugged in 4, we had 2 dots.
Yeah, on the y-axis.
Yeah, so like, that one, yeah, so that one means it's not a function. When there's 2 dots for the same x value, that means it's not a function. So yeah, scroll down to the other ones and see. B looks okay.
This one's wrong right here because it has these.
Perfect.
So that would be like one error, right? Is there multiple?
If there's,
that would be weak.
That means it's not a function. If there's 2 dots that are like vertically aligned with each other, that means you plug in an x and you can get 2 different y values. So B, yeah, is the one that doesn't.
Is that the only way that it wouldn't be a function, or is there other way, like other things that can make it happen?
In terms of the graph, yeah, that's pretty much the only way. Here, let's do this one, and then we'll save and exit because I'll explain something that'll make it more clear.
I'd say 3, right?
Yep.
Restricted.
Because there's 3 spots where it lines up. Okay, save and exit. But hold on. Oh yeah, actually yeah, that's fine. Yeah, no, you can save and exit. So there's an easy way, which is what we've been using. There's an easy way to tell if a graph represents a function or not, and it's by passing the vertical line test. So your question was, is that the only way? Is that the only thing that makes it not a function? And the answer is yes, but we've only seen like dots. So this wouldn't be a function, because if I drew like vertical lines, to pass the vertical line test, this is what this is. It's the vertical line test. To pass it, which means you do have a function, anytime you draw a vertical dotted line, it should only touch one thing at a time. So here it works because this vertical line only touches one thing at a time. Here it works because it touches one point at a time. Here, this vertical line touches more than one thing. So that means this function, which is just the blue dots, well, it's actually not a function because it fails the vertical line test.
Oh, okay.
The thing that we haven't seen yet is if we have something like some continuous function where it's not just dots, but the same test can be applied. If I can draw a vertical line anywhere and I only intersect at one spot, then it passed the vertical line test. So I can draw a vertical line anywhere and they all only intersect at one spot. So this is a function. The opposite of that, so like, let's see, if I have this, so this function, if I start drawing vertical lines, like, okay, that passes because it only hits in one spot. That passes, only hits in one spot. This fails because I hit in more than one spot.
Oh, okay.
So that's, like, you can think about it, before we just had points where they all lined up vertically. That means it wasn't a function. This also fails the vertical line test. This blue thing is not a function. Does that make sense?
Okay, yeah.
So it's really like, are you able to draw a vertical line, and does that vertical line only touch in one spot? And if it does only touch in one spot, then you do have a function. If it touches in more than one spot, then you don't have a function. And that's why when you have like two dots that are above each other, like, it's failing the vertical line test. So
okay.
Yeah, that's pretty much it. So vertical line test tells you whether you have a function or not. To pass the vertical line test, that means any vertical line that you draw only touches in one spot. And to fail the vertical line test, meaning you don't have a function, you touch in more than one spot.
That doesn't seem too hard. That one seems like those seem kind of easy actually to figure out.
Yeah.
On a graph, though. You know.
Okay, what does this say? Which statements apply to the ratio of rice and water? Rice and water. Okay. So on this, I think it helps to think about the scenario. Like when you're making rice, you don't figure out how much water you have and then choose that amount of rice that works with that amount of water. You pick the amount of rice that you're going to make, and then you use that amount of rice and you see, okay, now how much water do I add? Does that make sense?
Yeah.
So that means the rice, you can choose whatever rice that you want. And depending on how much rice you have, that decides how much water you need to use. So the rice is the independent value. Like it could be whatever you want, but the amount of water is the dependent value because the amount of water that you use depends on the amount of rice that you're using. So the amount of rice is the independent value because you could choose however many cups of rice, but depending on those cups of rice, that determines the water. So the water is the dependent value. So
Okay.
amount of rice is independent. It could be whatever you want, but the amount of rice dictates how much water you're going to use. So the water is the dependent value. And usually, same idea. The x, the left side, the x is independent. The y is the dependent value. So now we have the input, the x, the domain, and the independent. Those all mean the same thing. And the y, the output, the range, or the dependent, those all mean the same thing. The table shows order pairs of functions. What is the value of y when x equals 8? All that means is plug in an 8 in that equation on the right side and then figure it out.
So if you 28.
So it'd be 8 minus 2 times. So 2 times 8 is 16. Because you have to do the multiplication first. If you're just plugging it in. So 8 minus 16 would be negative 8. Do you understand what I'm saying or no?
No, I was wondering. From what I see, like the table order pairs of the function shows y equals or whatever x or it's a -2.
Yeah.
Oh, okay.
Here, scroll down to the answers. Yeah, I think it's.
Yeah, 48.
It's -8. Let me y equals 8 minus 2x. I think this will be really simple. So just click the -8 and then save and exit.
-8. Okay.
All right, so it's saying what is y when x equals 8, right? That's the question.
Yep.
So all you're doing is plugging in 8 for x. So y equals 8 minus, and then I'm going to have the 2, and then replace the x with the parentheses. And then I'm going to put an 8 inside. But we have to follow the order of operations. We don't do 8 minus 2 and then times 8. We have to do the 2 times the 8 first, or the -2 times the 8.
Yeah.
So that's where we get -16, because -2
okay.
times 8 is negative 16, and then the 8 is there. And then,
see, I didn't follow the order.
Yeah.
And then how'd you know? That's just the formula. It's multiplication because it doesn't show like a little dot there. I think just.
Yeah. Anytime it's like right next to it, this will be common for functions. It'll say like y equals 5x plus 2. That just means multiplication.
Oh, okay.
So like they'll give you different functions. These are called functions. Like this thing is a function. That equation is also known as a function. And you can plug in anything that's in the domain, any x value that you want. So like on that table, I think another x value was like negative 3. Well, we could plug that in too. So y equals 8 minus 2 times negative 3. Negative 2 times negative 3 is positive 6. And then, so we should get 8 plus 6, 8, 9, 10, 11, 12, 13, 14. On the table, is it 14 for the negative 3? Like x is negative 3, y is 14?
Yeah.
So, I mean, you could plug in anything you want, but it's saying, what is y when x is 8? All that means is plug in an 8. And then so we get 8 minus 16, that's negative 8.
Cool.
Those ones, I think, once you do a lot more of them, those ones will become really easy.
Yeah, I feel like that one's not too complicated enough.
Wait, we didn't finish that one, did we? Hello? Hello? Hello?
Hello?
Hey,
Yeah, my freaking router. I don't know why it reset. So
it'll save though, right? Like,
yeah, it should. Every time it's kicked me out, it's always saved.
oh, okay, good.
It's never really like at least so far.
So the things on this one, like so far, it's just been the x values are the same as the domain, which is the same as the input, which is the same as the independent value, and then the y value is the same as the range, which is the same as the output, which is the same as the dependent uh, value. And then just plugging stuff in, maybe. I think we're on like number 7. So
Yeah, this one it doesn't seem too bad.
yeah,
It's just the introduction, so
yeah.
this thing's taking forever.
How many pre-tests is it
Per course,
before like an actual test? Before it's like 15 or 20 questions or whatever?
I would I'd say like 5 maybe. I don't know. So I think some are different because the last one I had like 2 actual like topic tests.
Okay.
So I think maybe when it gets to like course 5, it's a little longer, and then the last course at 10 will be
Okay.
because these ones are going to be. This one went kind of quick because after we did the first test, it was like at 23% already. So I think I just got to do these courses and then the one course of algebra.
Okay.
That'll be it.
I feel like
priority.
the algebra is probably it's the same stuff except for just like more complicated. Like it's the same concepts but just with more complicated things.
Yeah, I'm sure.
But who knows? I don't know what they consider it. It might be a little bit different.
Yeah, I'm sure it's different than what you are used to teaching, right?
Yeah, it might be because this stuff is like in algebra 1. This is what we would be teaching.
Oh, okay.
So like, so that's what it's like. It's weird to me because they're saying one course of algebra after this, but this is algebra.
Thinking algebra. I thought this was pre-algebra.
This is algebra. It's like the.
Shit.
I'm thinking they think algebra, or they're considering algebra might be like the stuff you do in algebra 2. But who knows? I don't know. It might be just might be different. We'll have to see. Is it? It's not loading.
No, it's giving me some freaking error.
You may only have one browser session open at a time.
It usually lets me in once I click OK after that.
Let's see.
Come on.
You might have to close everything and then start again. Is this a Chrome? Do you? Huh.
Yeah, it's Google Chrome. I'm gonna give me an error. Usually it tells me someone's logged in.
Yeah, it's different.
There's only a few questions left, right?
Yeah.
So usually it tells me this, and then it lets me in. Last time it just there we go.
All right, sweet.
So we did. This is the third one, I think, or fourth time. This is the fourth one.
This is the fourth
So
one.
probably, yeah.
Oh wow.
We're already at 53%.
So once we finish, also maybe there's like 3 more after this one.
Once this one's done, we'll probably be at either 60 or 70%. So there'll probably be one more in the test.
Okay.
Once it gets to like 85, that's when it gives you the pre-test.
Mm.
And then you finish the course.
Do you remember how to graph the ordered pairs?
That represents a function. So I'd have to take one of these off.
Yeah, so which ones do you have to take off for it to pass the vertical line test? There's two options. Yeah, it's that one or that one.
Yeah, so it's telling you right here. So it'd be the 1 or the 3.
Yeah, the one. So one, the one means like if you start at the very center. The 1 means move to the right 1. The 3 means move up 3. So it's that top point. Do you understand what I'm saying?
Yeah. So to keep the, well, it doesn't say anything about keeping it here. But, no, wait, go ahead and say it again.
So it's asking which ordered pair could be removed from the graph to create a set of ordered pairs that represents a function. So it's saying which dot can you remove so that this picture represents a function. So it's one of those two that line up vertically, right? So if you take your mouse, put the mouse in the center of the graph. There, okay. So if I move to the right 1, so move the mouse to the right 1, and then from there move up 3, 1, 2, 3. That's one of the points that we could remove, yeah?
Oh, okay.
And that's why it says 1, 3.
Oh, okay, I see. So it's telling you what steps to move.
Yeah, that's telling you the position of that point. So that's one of the ones you can move.
It's not saying one of these two, because this one's at 1 and this one's at 3.
Right. It's not saying that. The other position would be 1, 1. That's also something that you could remove. Like if you put the mouse at the center again, the position, you have to move over 1 and then move up 1. That ordered pair would be 1, 1, but they're not listing it. So
I see.
Otherwise there would be 2 correct answers. Yeah. All right, I think you can get this one.
All right, so this one was just going to be 0, 3. We'll do this one here.
Yep. Pretty simple.
Yeah, no, those are.
Nice. Unless we got it all wrong, but I felt better about that one than all the rest of them.
I'll just see what the next one is.
Yeah.
Evaluating. Just write this down on my phone so I can see what I can see videos.
So evaluating functions, we kind of did that. Can I share something? Like a little blurb, and like I'll make up a couple quick examples. Okay. So evaluating. So evaluate. Let's say y equals 2x minus 3 at x equals 7. So this is like one type of problem that they might give you. Evaluate this function when x equals 7. All that means is plug in 7.
Okay.
So I would take this, y equals 2, replace the x with parentheses, minus 3, and then put the 7 in there. And then the
So that's
order...
not a negative 3, that's a minus 3.
It's kind of... Yeah, it's a minus 3. Yeah, you're not going to multiply by a negative 3. You're going to just minus 3.
I see.
The only time we're multiplying is when it's written like right next to, like that. Or if it's like 2 negative 3 plus, I don't know, 8. Then you would multiply. If it was without the parentheses, like 2 minus 3 plus 8, then it would just be 2 minus 3, see whatever you get, and then plus 8. But yeah, it's minus 3 here. You're not going to multiply by a negative 3. If it had parentheses, that would be different, but there's no parentheses here. So we're just going to do minus 3. So the order of operations is multiplication first. So it's actually parentheses first, then exponents. We don't have any exponents. Multiplication, then division, then addition and subtraction. So parentheses, there's nothing to do inside the parentheses, so that one's fine. There are no exponents, so we don't have to do anything there. The multiplication, that's the 2 times the 7. So we get 14, and then carry that down. There is no division, so that's done. There is no addition. The subtraction, so we do 14 minus 3, that's 11. So the answer, evaluate this at x equals 7, you would say y equals 11.
Oh, okay.
So that's one type of problem. Another type would be like, let's say, I'm going to call this is y. And 2, 4, 5. Okay. So evaluate this function. They might call it something else. They might call it like f of x. I'm going to call it y. So evaluate y, which is the function, at x equals 0. All you would do, because remember this is the x, this is the y. When x is 0, where does the graph touch? Well, it touches at 1. So evaluate y at x equals 0. Y would equal 1. When x is 0, the graph is at a y value of 1. Does that make sense?
Yeah.
If I said evaluate at x equals, I should have done a different, well, 1, 2, 3, 4. X equals 4. Here, I would say y equals 1, 2, 3, 4. Probably negative 0.5. Does that make sense to you? Because this would be negative 1, negative 2, and it's like halfway in between. Does that make sense? Hello?
Hello?
Hello? Does that make sense?
Yeah. Hey, it cut me off.
Okay,
you
so
were talking and it started cutting.
But if
yeah, I see what you're saying. Yeah, so
they're giving you an x value, so you just go there and then match it up and then see what the y value is. That's really all you're doing. So you can evaluate it If they give you like an equation for the function, just by plugging in something. If they give you a graph for the function, then you count on the x for whatever x they give you, and then just match it up and see what y value you get out.
Okay.
Those are two ways to evaluate functions, and there might be other stuff, but so far that's the small thing. But I'll talk with you tomorrow if you have time.
Yeah. I'm willing to do it. If you have time, if not, just text me. But I'll be trying it out. If not.
Okay, cool. I'll talk to you tomorrow.
Thanks, man. Have a good night.
You too. Night.